Welcome everyone. My name is Zinon Musmulas and I'm with GRNet. I'm also chairing this session, which is about digital content and actually different aspects related to the delivery of content. The first speaker is Jürgen Quist, and he will discuss an incident, the network incident related to a particular very well-known content delivery network. And this will showcase the ever-increasing importance that CDNs have for our events, for our community. Some of you may have noticed that originally there was a different speaker. It was the invited speaker, Emin Gunsire, who unfortunately could not make it to Iceland, as he informed us last week. So let's welcome Jürgen.
Could I switch the microphone? Yes, thank you. Yes, as I'm going to talk to you about something that is definitely not big science. It's a real down-to-earth incident, more involving the long tail of networking, the effects on a network when something happens that is related to something that shouldn't really be a problem, you would think. As you can see here, it's people skiing. Usually shouldn't be too much of a problem from a networking point of view. But what you can see down here, there's a small mistake here from my point of view. They're going uphill. Personally, I never really understood the purpose of that. I prefer downhill. It's more exciting and more convenient. And to be honest, it has nothing to do with what I'm going to talk about. So this event happened during the skiing championship that was held in Holmenkollen 2011. And it was, we didn't really foresee it. We didn't see it coming, but we didn't notice it when it happened. So the victim was definitely Uninet, which is the local NREN in Norway, and it was Nordernet and our regional network. And you can say the guilty person or the person infecting this on us was, in this case, Akamai and their brilliant distribution network. So what really happened was that there was this fantastic skiing event. Somehow they want to do it in Norway at that time of year. To do it, they need to do it in the middle of the day because that's when there's daylight. That means that everyone that wanted to see these particular cross-country skiing events, they were at campus, at whatever university, they were all at work or studying location at the time of the event. Which really was what caused the issue. There's one thing you should know, that basically all of the Norwegian internet infrastructure broke during this event. It wasn't just our network that was affected. A lot of the local ISPs backbones really just fell flat. So it was quite an interesting event, very isolated, but still there's something to be learned from it. If you look at the part of Northern network we are looking at, it's really up here with the Uninet, which is connected with a lot of capacity into the Northern backbone. And the Northern backbone itself, it's running between these 4 nodes with 40 gig. So, and that is basically the core infrastructure that it ran into in terms of the Nordic network. We do have an international network where it's used to collect all the traffic from the internet, basically. We have a quite extensive peering network where we collect to the big X's, like AM6, London X, a couple of X's in the US. But for this particular incident, it's really in this area here that's interesting because US wasn't really involved in this incident at all. So what we could see was that, generically speaking, we get about 80% of our internet traffic through peering, and yes, there's a bit of it that we pay for. And that's basically the background for what I'm going to show you in terms of graphs and and the flows of traffic that we saw. So basically what happened was that people started their cross-country skiing, and everyone switched on, and basically this is what you see is the major links going into Norway. They just fell flat. They couldn't take any more traffic whatsoever. So this traffic of live streaming just exaggerated everything else. And why did that happen? Well, the thing is that Norwegian Broadcasting have their nice website, and they do also send out the broadcasts with multicast, and the multicast signal was actually available throughout the network all the time. The only thing was no one was watching it. Because what happened was everyone that wanted to see this went onto the broadcaster's website, clicked on the link, and they all got their own unicast session. And the Norwegian Broadcasting didn't really want to do all this with the CDN themselves, so they had an agreement with the ACMI. And that is nice. Within Norway, Uninet has a connection to ACMI with a few gigs, but it didn't really help them much. So what we started to see was that as the ACMI network realized that it couldn't just deliver all the traffic in Norway, it started pushing the traffic through their nodes throughout Europe. And as we peered directly with ACMI in a number of locations, what we saw was that those locations suddenly had a bit of a traffic more than they used to have. This is our connection at Amsig. And yeah, it suddenly went not all the way through the roof, close enough. We did see some traffic on the links connection, and we did see some traffic from the net node in Sweden. And basically, this is really the effect. In terms of the incident as such, I think we was really, really lucky that the links into Norway was kind of the stopping factor. I'm pretty sure that had we had more capacity into Norway, we would have really strangled the whole of our backbone, because it looked at the time that there was no limit to how much traffic you could actually draw into Norway at the time. So from a Northern network point of view, we survived, but we only survived because the links into Norway weren't big enough to really strangle the core of the network. So what can we do? Well, there's a couple of things that we can do, or anyone could do, that if you suspect you are in the same situation, you can connect ACMI or whoever CDN you're talking about directly to your network core to avoid your, in this case, our peering network, because that was really where the strain was that was suffering. So you can avoid that by connecting any CDN into your core, but it might be useful, it might not. It's definitely not cheap to do it, but it's definitely an option that you can do it. Another thing that we definitely impose now as a design measure is that we do not allow an NREN to connect with a capacity that can really overflow the backbone. Because this is really what saved us. It was not by design, it was by accident, more or less. But this is one of the things we actually implement into our design rules now, that we do not allow a single NREN to actually overflow the backbone, just by regulating which access speeds they can have. But the truth of it is that if it had not been skiing, if it has been I don't know how to put it for the Norwegians, if it's been a serious sport with interest in a lot of countries, it could have been different, because even though we say that Norway can't connect with more than 30 gig at the moment, and the FUNET from Finland can't connect with more than 20, and the Swedes can't connect with more than 40 gig, and we design our backbone to whatever level. If everything hits the fan at the same time, well, pray. Or you can start to do other stuff. There are stuff you can do with rate limit policies. You can take all the AESs from the CDNs and put them into a special MPLS session that you only allow at certain speeds. But with the network that we have, at least, we really, with a transit network for the NRENs, we don't want to impose any policies. But we could be forced to it, because if this really happens, that there would be a really big sports event that would take place at the wrong time, meaning during daytime, we could be forced to just to protect the network traffic where people actually do other things that watch sports. So you could be forced to. We really would hate to do it, but we have actually looked at some methods and tested some methods where you can actually do that if we see that we have an event like that coming up. We're not going to just like block the traffic, but we're going to do some rate limiting to avoid it from actually ruining the rest of the network. So, should we be scared? We have these things coming up. And when I first saw them, I was actually a little bit concerned because that was just after the skiing incident in Norway. But should we worry? No. And the thing is that we shouldn't be worried as entrants. If I was sitting in a lot of other networks, I really, really would be worried. But the reason why I'm not really that worried, well, it's during the summer holidays, so there's no one that will be at campus. But if I was running an ISP somewhere, I really, really would be concerned because someone is going to watch the Olympics 100 meters final, trust me. And a lot of them will do it over the internet. Be sure of that. So I think that's going to be one of the tests. You can see how good are the networks really, and how good are they to sustain a strain like that. Another aspect of CDN is really what I call cloud services. Cloud services, as you can say, is it's everything. It's whatever Google provides, whatever Box provides, whatever provides from the net. But there's one thing that's common for them. They all use CDN to distribute the data. It's not like like you see with the sports events. It's one big thing, but it do have an impact. Today, if you see the way universities work, all of their traffic is almost east-west. Yes, there's traffic to the internet, but if you look at all the campus services that they have, they do mainly run within the campus. But what happens when all the thing changes to cloud? Well, the future traffic flows is going to be different. Universities really start to use these services. They use Google Docs, they use anything as a service, infrastructure as a service, platform as a service, whatever you do. But one thing that is really, really common for all of them is that the traffic flows is north-south. Everything goes through the internet. And another thing is all the desktops and portable things that people start using. It's going to be worse. Everyone uses Dropbox, Box, whatever, to back up their stuff. I mean, the home catalogs is gone. It's in the cloud. And these things is really, really more than anything else going to change the way our networks is going to be used and it's going to be structured. This is a nice graph from the Northern traffic with Google. And this is where we got really close to one of their caches. And they were able to actually really, really push the traffic a lot faster. What we really see, this traffic graph is just for over 2 years. And you can really see that traffic is growing. And yes, it is just that it will happen. It happens with all of the net services that we see. We have statistics from other big cloud providers where we have similar traffic patterns. It's just at the beginning of the ramp, and it's going to be even worse. So, well, the good news is that you can predict major live events. Just take care, read the papers. You will see, and you were able to predict when they come. If you're lucky and interested in sports mainly, you should be able to see it. Not just sports, actually. We had another incident that was similar, that was triggered by a royal wedding. But again, you can predict these events if you really take care. The impact of cloud, content, social media, etc., it can be foreseen. And it's not going to be like a big thing that happens overnight. It will happen, but it will happen over the next couple of years. I think right now we have just seen some of the services, they're starting to use Google Docs and smaller stuff like that. But it's really when they pick up the infrastructure as a service or platform as a service big time, because that is when you will see the really big traffic flows shift. And we're just beginning to see that. So yeah, it's happening, so be prepared. But there's one thing to remember, it's not the fault of the CDNs. They just have a business model to distribute data from the big content providers. So the good thing is work with the providers, work with the Akamai's, the Limelight, the Level 3s of this world, because if you work with them, you can really get some sensible connection agreements with them. You can connect them in a network where it suits you. So I think this is really the message. They have a business model, and it works for them. And for us to make it work, we need to work with them. So I think this is really the message that I want to have here, that you just need to work with the distribution networks, because they do also have an interest in that the content is actually distributed in a controlled and manageable way. Any questions?
Something I want to add to this discussion, which is relevant, but it's not exactly the same. And we can also see if there are any other questions about this or other issues, is related to a discussion that has started in Alternative Media recently. And it has to do with, okay, there are these CDNs which are, have a global presence. They have a very familiar business model and how they work and wherever they work. But there's also the fact that the NRENs, as well as not just NRENs, but also commercial ISPs, are often faced with such traffic tsunamis, which are sometimes related to a very temporal event like a sporting event or something like that. But there can also be other ways of this can happen. And the question is how NRENs and other providers, but in our case we're only interested about NRENs, how could they better handle such traffic? Because I remember that you mentioned at some point that there was a live stream which was multicast in the network, but nobody was using it. Yeah. So there has been a discussion about how NRENs could specifically sort of collaborate to join initiatives such as CDNI, it's called, some sort of collaboration between smaller probably CDNs, which could peer directly and exchange content and help each other and help their business models. Usually, this is of course the fact that the CDN has a business model and it always targets its business model. But in the case of NRENs, there would be other benefits as well, as I mentioned previously. So that's a question maybe. That's if NRENs see this happening or have an interest in that, and feel free to ask any other questions as well. No reactions? I did bore you.
You have indicated that you have changed some of your ingress rules to prevent flooding of your internal network. Is it possible to work with the CDNs to prevent them from sending you so much data as well? You said that you were trying to work with them. I mean, can you just ask them, if it gets to this point, stop?
It's definitely one of the options, but the issue from their point of view is that they do have a mission from their customers to get if it's a live signal, as much of it out as possible. So yes, we did discuss that they must understand as well that we do not have unlimited capacity within our networks to support those types of events. But we do not really have had too much of a positive reaction on that specific argument with them. So what we are pursuing is rather than we try to connect what we believe is sufficient capacity from them directly to the core, and then the rest of it we'll take to our peering networks. And so far we think that will be sufficient, but as I said, we do have some backup measures if it's not enough. And that is definitely something, if we impose that will impact what the CDNs can deliver to their customers. So if we really do that at some point, maybe the discussion is going to be different.
More questions? No? In that case, thank you very much. Just leave it there. Yeah, okay. So now we have a second presentation, which is more research-oriented, and it is somewhat related to something that we have already heard about in the keynote from EVE Online. It is about next-generation architectures for optimizing the game. Optimizing game architectures for deployment on cloud platforms, and new ideas and mechanisms to get that to happen. The presenter is Wouter Wammenford, who is representing a rather large team, research team at IBBT and the Center for... you're going to mention that. Let's welcome him. Okay, go ahead. You can use this? You prefer that, using that?
Okay. Good afternoon, everyone. Like Dan also already introduced, I'm Wouter van Montfort from the Expertise Center for Digital Media in University of Hasselt. And I'll introduce you to some initial research we did where we tried to combine a fine-grained bandwidth shaping technique into server architecture for a large-scale networked virtual environments. So, first of all, what are networked virtual environments? Simply put, they are virtual worlds where many users connect to and interact with each other. So basically, it's just like massively multiplayer games like EVE Online or World of Warcraft, but also more collaborative oriented virtual environments. But if you want to develop a large-scale network virtual environment, you always run into a problem of scalability. And there are several aspects to the problem of scalability, and one of them is there's always certain risks involved, because from an economical point of view, if you want to develop a massively multiplayer online game, you don't know upfront how popular it's going to be. So you don't know how much hardware you have to buy, or if you buy too much hardware and the game isn't popular, you would have wasted a lot of money. But if it turns out to be very popular, but you have only a few servers, well, the users will get dissatisfied because they will have high latencies. Another problem of the scalability is that you always have some limited bandwidth available. Certainly, especially for the connection to the clients, they have always a pretty limited bandwidth. So the first step in creating a large-scale networked virtual environment is a good scalable network architecture. And one of those is LVIC-NG, which was designed several years ago at our research department. What differentiates LVIC-NG from custom client servers, normal client server architecture, is that we introduce an additional overlay network of proxy servers. You could argue that adding an additional layer introduces some extra delay, which is true. But on the other hand, it allows us to flexibly, it allows us to hide the topology of the inner game servers, which are called logic servers in LVIC-NG, which is a great benefit because it allows us to how must I say, change the logic servers, the topology of them. But I first have to tell you a little bit about if you create a virtual world, it's impossible to just send all data from all the objects and all the clients in the world to the clients, and it's also impossible for just one server to handle it if you've got many servers, many clients, and many objects. So what's commonly done in NVEs is you split the world up in several zones or regions, and you assign them to your game service. What makes LVNG rather unique is that there is no fixed mapping between those regions and the service that run them. So this allows for a very flexible architecture. But the problem is that now the proxy servers don't know which regions are run by which logic servers, and this is where the region management system comes into play. It is towards a proxy server, it's like a DNS server which maps the regions to specific logic servers, and on the other end, it also functions as a load balancer for the logic servers. And one advantage is also that it allows us to add and remove logic servers when the load is low or high. So this flexible architecture allows us is a really good candidate to be dispatched on a cloud platform, which is something that's currently we're doing research into in another project. The architecture also supports sharding, zoning, and instances, which are rather common in network virtual environments. But also unique in this LVNG is that the zones don't have fixed sizes, but depending on the load in the zone, we subdivide them further and distribute them among different logic servers, which is also shown here in this image. The different colors represent the different logic servers. As I already discussed, to have a manageable network virtual environment, we have to split up the world into different regions. Mostly one region is handled by one server, but one server can, on the other hand, can handle several different regions. As I haven't really mentioned it, the regions, like yes, you can see in this in the image, they are dynamically split up and merged based on the load in the server, and then the zoning was firstly designed for reducing the load on the logic servers, but then again, it's also a coarse form of bandwidth reduction, because you'd only have to send information about clients inside the same zone and possibly in the zones that are surrounded by that. But if you have, for example, mobile users which have a very limited bandwidth, you want to have more fine-grained control about the bandwidth, and that is where area of interest comes into play. If you talk about area of interest, one of the first research papers that covers that presents the Aura Nimbus focus model, which is shown in the left bottom image, where each object in the world has an aura assigned, and if the aura of two objects collide, we'll start looking at the focus and the nimbus of those objects and see if they overlap. And if they overlap, they'll start interacting and send information to each other. In our research, we use a little more simplified area of interest system, where we just have a few areas, simple shapes, and if an object enters the shape, it starts sending information, and otherwise it doesn't send information to the client. For our research, we created a small but generic library, which we call the Area of Interest API. At the core of it is our interest definitions, which are just a grouping of area definitions. And like the name says, the area definitions are just a definition of some sort of area. There are several shapes that this area can have, so like is shown in the images on the right. One of the advantages is also that we can dynamically adjust the parameters of these these areas, and they also have a certain level of detail assigned to them. Level of detail is shown on the bottom left. If you can think of an object that is approaching from far away and coming closer to a certain client. If he's far away, you don't want to receive information about it, but as it comes closer, it intersects with the first large circle, and it starts sending its position information, for example. As it moves closer and closer to the player, it starts also to send more and more detailed information. So by using the dynamic parameters of the area of interest and the level of detail, we can influence the available, we can influence the bandwidth that a certain client will receive. But we don't yet have a technique to really control the bandwidth to the client. So this is where another research project comes into play called the NIProxy, which stands for the Network Intelligence Proxy. It's a server, a standalone server, in its original setting. It's a standalone server that provides traffic shaping capabilities. Internally, it uses a set of a stream hierarchy, which consists of a bandwidth shaping tree, where the leaf nodes represent the different streams towards that a client is interested in, and the different inner nodes represent different bandwidth distribution strategies. To explain a little bit how it works, you can see the image at the bottom, where there is a collaborative environment where some users are sending video data to each other, but as the connection of for example, mobile users degrades, he doesn't want to receive the high quality video because it's just not possible, and it gets a lot of stuttering. So what the NIProxy can do is transcode the video and send a lower resolution version towards the client effectively, and by that it can reduce the bandwidth that's used and stay within the bandwidth limits available. So, so we have three different techniques or libraries that we use, but we need to combine them together. And at first, the NIProxy was developed as a standalone server, so we didn't want to introduce an additional server into the architecture. So we integrated it with the existing proxy servers in the LVIC-NG framework. So some modifications were needed, but in the end, the core of the bandwidth shaping tree, that was most important. Also because the area of interest, the API library, is a generic library. It isn't really integrated with the LVIC-NG. We need a way to pass the packets from LVIC-NG to the area of interest library. I will now show a little bit example of how the eventual bandwidth shaping trees look like for the area of interest technique. In comparison to the original NIProxy, they're relatively simple. You have a root node and several leaf nodes which represent different interest definitions. I will just continue. Now we have all these techniques, but do they really work? And that's one of the research questions that we try to solve. Therefore, we conducted several experiments from small scale to larger scale. But to make the technique a little bit more clear, I will show a very simple and small example of a first-person shooter setting where there is a client, a sniper, which is located in the middle of the map, and there are two enemies that are circling around that sniper, as you can see here in this picture. because we want, because we need, go a slide back. Something I also have to mention is we need some kind of heuristic to couple the different area definitions of the area of interest API with the bandwidth shaping tree of the NIProxy, because it needs to know how much bandwidth is a certain area of interest definition going to use. To do this, we see what you see here in this image is our three configurations of those area definitions. In configuration 3, which is as the highest level of detail, you see that the sniper has a very large wedge shape area, which is focused on the outermost player, and also it has a little less lower level of detail assigned to it, and it also has a large circular shape attached that has a high level of detail. The second configuration is used for if the bandwidth is somewhat less. As you can see, the shapes are modified, so the wedge shape is not the angle of the wedge shape is reduced, and the inner circle of around the sniper is also reduced. As you can see in the image, this way the enemy between the sniper and the outermost enemy doesn't send any more information to the sniper. So we have a somewhat of a bandwidth reduction. The last configuration of, not really last configuration, but is just a very, very, very small area of interest. It's not really visible on the image, but it only sends information from the service to about the client itself. So it only sends its own position updates, which, for example, would represent a condition where we have very, very low bandwidth available, but you still want the player to be able to move around in the virtual world. It's not. It has very reduced consistency for the virtual environment, but it's better than just a very laggy movement in the virtual world. As I said, we use we need some kind of heuristics that map the expected bandwidth uses of the different interest definitions of the area definitions to the specific configurations. And in this example, we show two cases: the worst case and the best case, and the worst case scenario, where in the best case, the heuristics are very close to the actual bandwidth that was used when a certain configuration is activated. In the worst case, we have just we wrap it all around, and it's the first configuration which should be using the least bandwidth. We tell it that it uses the most bandwidth, but as we see, our technique will be able to somewhat cover the worst case heuristics. So in this image, a graph is shown of how the bandwidth changes over time. At first, we have a lot of bandwidth available. The gray line represents the available bandwidth, and the red line represents the actual bandwidth that's used. So at the first, the NIProxy notices that there is a lot of bandwidth available, and it selects the third configuration with the highest level of detail and the most bandwidth users. But it's okay, since there is a lot of bandwidth available. In a certain time, about 20 seconds into the experiment, we reduced the available bandwidth, and after a second, the the NIProxy notices this and looks at the heuristics it has and notices that the configuration 1 would be the most correct interest definition of configuration to use in this case to still be inside the available bandwidth. So it, as you can see, it just keeps by switching to the configuration, the first configuration, we still remain inside the available bandwidth. Of course, as the experiment progresses, the available bandwidth shifts again, and all the configurations get selected correctly for the best case scenario. But what's more interesting is what if we use the wrong heuristics for the different configurations. As you can see, in the worst case heuristics, the NIProxy thinks that the first configuration will use the most bandwidth, and at the first it activates the first configuration, but after a second it notices that actually the first configuration uses more actual bandwidth than the heuristic suggested. So it updates the heuristic of the first configuration and then activates the next possible configuration, most obvious configuration, which is the second configuration. But as you can notice, the second configuration is using suboptimal bandwidth because there is a lot of bandwidth available, and actually it should have been using the third configuration with a high level of detail. But because the NIProxy thinks that the third configuration uses very few bandwidth, it doesn't select it. Then the experiment progresses and the bandwidth changes again to a lower value, and because the NIProxy updated the bandwidth, actual bandwidth of the first configuration, it activates that one again, and then again the bandwidth available bandwidth rises, and because of the heuristics, the NIProxy again selects the second configuration. Now, what's interesting to note is what happens when the available bandwidth drops really low, because the NIProxy thinks that the third configuration, which actually uses the most bandwidth, it thinks that it uses the least. So it tries to activate it, but that will result in a huge bandwidth spike. And this can cause, of course, problems because you will overload the network. But again, because our implementation checks if the actual bandwidth corresponds to the heuristic, it updates the heuristic and selects the other correct configuration, which is in this case is just disabling all information sending. So as the experiment progresses further, it will correctly adjust the bandwidth available based on the available bandwidth, because now it has changed and modified the heuristics to the correct values. One important thing to note here is also that if we wouldn't have hit the very low bandwidth limit, the NIProxy would have never selected the third configuration, and it will have never known that it actually uses a lot of the most bandwidth, and it wouldn't have selected it here again. So that concludes the simple experiment. We also included other experiments, but I'm not going to cover them here because it would take way too long. So we conclude that the combination of the LVIG architecture with the area of interest, API library, and the NIProxy is a viable approach to reduce the bandwidth in a fine-grained manner, which can result in a better quality of experience, which is not to be confused with the quality of service for the users. But of course, there's still a lot of future work to be done, because when in the larger scale experiments, we noticed that there was very weird results we were getting, and they were mainly because of the bad, I like to call it the research code status of the LWNG architecture, which isn't really optimized yet. So there's a lot of work to be done there. Also, like I mentioned in the beginning of the presentation, we were investigating how we can use the architecture into a cloud infrastructure. And also important is to note that there's also always a trade-off between the consistency a player gets in the world and the available bandwidth. So if you reduce the bandwidth, if you have a lot of bandwidth, you'll get better consistency, but if you lower the bandwidth usage, you'll probably get less consistency, and it's bad for the quality of experience for the player. So this ends my presentation here, so if there are any questions, feel free to ask.
Thank you very much. Any questions for this presentation? Okay. Thank you. Thanks. So the next presentation is about a European project called EU Screen, which aims to bring online and deliver in a very large audience decades worth of material, of television archival, of audiovisual archival material, and do this also through Europeana, which all of you know. Let's welcome Johan Oomen, who is with the Dutch Audiovisual Archive, I think. Yeah, thanks. Let's just change the slides.
So, good afternoon, everybody. Let me just... You can
use this if you want.
Okay. I'm aware of the fact that you've been listening to presentations and watching PowerPoint slides for many hours now. And I'm also a bit tired. So I hope to keep it short. And I also have two small videos in my presentation, just to lighten up, the presentation itself. So my name is Johan Oomen. I'm head of research at the Netherlands Institute for Sound and Vision. Sound and Vision is one of Europe's largest audiovisual archives. We look after 750,000 hours of audiovisual content collected over more than 100 years. And similar to other audiovisual archives, we are now in the process of digitizing that collection. We do that for two reasons. The first reason is that if we don't digitize our analog holdings, the carriers will, the carriers are very fragile. So on one hand, we are digitizing for preservation. On the other hand, we are digitizing the material to make it accessible to many types of end users. So we are developing, similar to other audiovisual archives, online services that repurpose this material. And this is sort of the context of my talk. So it's about what you can do with audiovisual collections becoming digital and becoming available on the web. So in a nutshell, I will be talking about a project called EU Screen, which brings together 19 audiovisual archives, both national audiovisual archives as well as broadcast archives. We started in October, and we will finish this project in September. we have, in the course of the project, we have established a foundation, the EOScreen Foundation, and the EOScreen Foundation will make sure that the service will remain online, and also make sure that more archives are joining this initiative. So one of the core things that we've implemented, and I think it's most relevant for this audience, is that we made an implementation of the EBU core, which is a metadata standard now used across many audiovisual archives to make sure that collections become interoperable. So as was already mentioned by our chair, we are doing this project in the context of Europeana. I'm not sure how many people know about Europeana. Maybe we can do a raise of hands. Oh, that's very poor. So just for those who don't know, a very short, digest of what Europeana is. And so here it goes, the first video. I hope that the sound is going to be very loud and stuff, just to keep you all awake. So in short, Europeana is a pan-European project that links together 2,200 collections across 33 European countries. And it makes it available through this website, but also through an open, accessible API. And this project is quite significant because it's the first time that so many institutions are working together in bringing this content alive on the web. So if you go to Europeana today, this is just a couple of screenshots. So you can make queries, and then you can make a selection in different content types, like text and images, videos and sounds. So this is an example of where I then just go to different videos. You can also filter in different languages. And eventually what happens is that the content is shown in the original context. So that means that Europeana serves as an index of metadata. Europeana itself doesn't host any content, but rather it links to the content residing at the different contributing archive sites. So an incentive for archives to contribute to Europeana is to drive traffic to their website. That's just one of the added values of connecting to Europeana. So this is the only sort of technical slide I have in my presentation. There are two ways in which metadata is submitted to Europeana. One is through domain aggregators. Domain aggregators typically look at say topic. For instance, there's the domain aggregator for film, domain aggregator for libraries, for theater, for fashion collections, etc. And there are so-called national aggregators. National aggregators, they operate, well, as it says, within borders of a country. For instance, there's a national aggregator in Germany, national aggregator in France, and they are also contributing collections to Europeana. The reason why Europeana is working together with these domain or national aggregators is that it's impossible for them to manage 2,200 single collections. You have to imagine that Europeana is managed from one floor in the Dutch Royal Library, so there's a small team of people that are looking at metadata and ingesting it in the central index. And the only way to make it manageable is to distribute it to work. So working with these domain or national aggregators makes it easier for Europeana to handle all this content that comes in. So if you start from the top, so the Europeana logo, you can say that's the Europeana index. So what happens? Users, they search the index and then retrieve metadata and then link to the original content residing at the different underlying sites. So the Europeana website is only one way of accessing this collection. I think by far more powerful way is the API that Europeana offers. So this makes it possible for third parties to implement new applications on top of the Europeana collection. And in order to sort of kickstart this idea of building applications, Europeana is hosting a series of so-called hackathons where they invite developers to play with the API and showcase the different services that you can build on top of the API. It is, let's see, oh yeah, okay. So one more thing about Europeana is the fact that building this central index of open, accessible and aligned metadata is one big result of Europeana. The other one is, of course, the fact that Europeana is bringing together all these libraries, archives, museums, so the network of Europeana is also very valuable. So one of the things, for instance, that has a big impact is the work of Europeana regarding the advocacy. So the metadata that Europeana is making available is licensed under a so-called Creative Commons CC0 license, which means that it's actually contributed to the public domain. So it makes it very transparent for third parties to make use of this metadata. Okay, so if you look at Europeana today, they bring together, like I said, 2,200 collections, and this accounts to over 23 million objects. Of this collection, 2 million objects are available in the public domain. So in principle, they could also the content themselves, like the pictures or the scans, could be are in the public domain and can also be used. But in principle, the Europeana deals with metadata. There's a big gap regarding the audiovisual content. So these are very ugly pie diagrams I stole from one of the Europeana reports. But what the takeaway message from the pie chart on the right is that only 1% of the total holdings on Europeana are from audiovisual collections. There are many reasons for this. The most obvious reason is that it's still quite difficult for archives to clear the copyrights of their collection to be viewed online for free. That's I think by far the reason why there is so little material available from audiovisual collection. The other one, of course, is that it is very costly to digitize audiovisual holdings if you compare it, for instance, to digitizing photographs. Okay, then we go on to EU Screen, also, so the EU Screen, as I said, is a 3-year project which we are now in the final stage of, and this video gives you some sort of feeling about the collections that we make available. It's a 2.5 minutes video.
Have you ever thought of traveling through time to see how our ancestors lived and to discover what they thought, desired, and experienced in their youth? Or do you, as a grown-up, want to remember your own past and your own history? Can you remember the first TV transmission you watched, or the face of your favorite TV presenter? And what about your children and grandchildren? Have you ever thought of teaching them about significant events? How would you decide what they needed to know? And from which perspective should this story be told? The past century has been intensively documented by images produced by television. These images may differ from country to country and may offer different and sometimes opposing views on the same historical event or controversial issue. Audiovisual archival material has been difficult to access for many decades, but now EU Screen offers you the possibility to explore your cultural and historical past within and across different European nations. The site can help you reconnect with your own history and offer insights into the cultural and social past of your European neighbours. All you need to do is to select the period, the subject, and the language you desire, and start to travel through the history of the 20th and 21st centuries.
So this is a list of the archives that we are currently working with, so I'm sort of fast forwarding to my last slide about future work. There will be, we are now also in touch with the Bulgarian and Portuguese television, and also with the Finnish public broadcaster, Yle. So this list of broadcasters that we are working with and National Audiovisual Archives is growing and growing. So the idea was not to try and make as much content available as possible, but rather to build a very nicely balanced collection, giving insights into European television history. You have to imagine that some of these broadcasters started broadcasting maybe 70 or 80 years ago, and others only 20 years. So we needed to come up with a content selection policy that makes it possible to, for instance, look at different topics and then make a comparison between different era, for instance. So one of the things that we've done is make up this content selection policy. So every archive is using these themes in order to do their content selection. I will skip this one. A second challenge that we had to face also has to do with intellectual property rights. So this is a sort of continuum of the types of activities that end users would like to do with audiovisual content, ranging from only public viewing until remixing, so actually downloading content and making it as part of a new work, using it as part of a new work. And there are all kinds of things in between, for instance, creating playlists, quotations, etc., etc. But each of these steps, going from left to right, has implications regarding intellectual property rights. So we had to come up with a solution where we first have to find out how much we can do with the content. We knew that only a few archives would allow content to be downloaded and remixed. And we knew also that some archives wouldn't even allow their content to be embedded in external sites. But we wanted to really push the boundaries. So if content can become available for download, we would like to offer that possibility. And this has been very important in designing the website and the features on the website. So I would invite you to go to euscreen.eu if you want to take a look. I also brought some flyers with me. You can also take home. So one of the added values obviously is the fact that we are working with these different archives. They all have very elaborate metadata schema, and nobody is using a standard schema. So one of the results of this project is that we made all the archives comply to one core schema, which is the EBU core standard. And from a user perspective, that means that you can use all kinds of filters to really drill down into this collection. So on the right, you see some of the facets that we use, like language, the geographical location, etc., etc. And this is an example of a detailed screen. One of the features that we are going to be rolling out next month is a so-called exhibition builder. It's a very simple tool that we are using to create very simple online exhibitions. For instance, around a certain topic. We would like to invite end users to look at our collection and to say, okay, say you are a researcher and you are a teacher and you would like to give a lecture about children's television and how that developed across Europe. This tool will allow you to create a very simple exhibition which you can then share. And taking into account the copyright situation, sometimes you have to ask the archives for permission before you can include it in the exhibition builder. So this is one of the features that is built into this exhibition. But this is something that we will launch next month. Just some words on the back end. So as I said, the challenge was to make all the metadata interoperable, and to this end we developed this a whole workflow that goes from getting the raw metadata, which can be delivered in different formats, and then do a mapping to a common schema, and then do enrichment. For instance, all the items on the site have English descriptions and also have thesaurus terms that we are selecting from the IPTC thesaurus. And so using the thesaurus terms, we can provide some means of multilingual access, because the IPTC thesaurus that we are using is available in 13 languages. So this is a way to also search across different collections and across languages. I won't go into much detail here, but I would like to just point to you at this tool, which is developed within the project, and it's available as open source, and it's also now used not only within the EU Screen project, but across well, at least 6 projects contributing to Europeana. It's called the Mint tool. There's a link on the bottom right. Also, this presentation you can download from the Terina website, so that's quite easy. So for people that would like to have a tool that allows you to make a mapping between any given metadata schema and a common schema, then the Mint toolset is probably something you would like to take a look at. So what happens here is that on the left-hand side, you will find the XML that is that's like the source XML from the different archives, and on the middle in the middle plane, this is the EBU core schema that we use, and you can very easily make connections. For instance, you can say that the title. Say the Dutch word for title is titel. That titel actually relates to title in the EBU core. And then you can say, okay, this one connects to this one. This link is then stored. So the next time you are uploading a batch of content, you don't have to do the mapping again, but you just use the mapping that you already created. So this is something you might want to take a look at. So I'm now going to close by some of the other future work that we're doing. One is we are making our collection available as linked open data, as RDF, which is this is the domain you can get the data from. The idea here is that in opening up our collection, similar to what Europeana is doing, we hope that third parties are making new applications using this collection. One of the first things that we saw is this. Somebody created a timeline. It's a very simple timeline using the Simile framework. So this is another view on top of our collection, something that we didn't make ourselves, but somebody decided, well, I have a few hours of spare time and let's just play with this data. But we hope that that other developers will invest some time and effort into making new views on top of our collection. So on our project blog, you can find more information. For instance, we also listed here a collection of websites where you can find open data, so video that you can download using an open license like Creative Commons. So regarding future work, as I said in the beginning, we are adding more audiovisual archives. The idea is that EU Screen is going to grow as being the pan-European aggregator for audiovisual content. So it will have so both on the EU Screen website and also on Europeana. So all the content, maybe this is not clear yet, but all the content that we are making available on EU Screen is also being sent to Europeana. And the second bullet, so like I said, we decided from the very beginning that EU Screen should have a very well-balanced collection, and also the enrichment of metadata is very important into creating this well-balanced collection. But we also are aware of the fact that many archives are now starting their own, say, delay TV or archive channels on their websites, which will potentially, we could link to much more content. But then doing the enrichment will be very time-consuming. So we are now thinking about introducing a mixed model where on one hand we are just doing the aggregation of metadata and then linking directly to the individual broadcast sites, and only if a selection will be enriched and made available also on the EU Screen website. Maybe this is a bit abstract, but if you want to know more, I will be here and also tonight at the dinner. So I'm happy to take any questions. I've been talking maybe a bit too long, but anyway. This is my, my email address and my Twitter name, if you'd like to find out more.
Hi, nice project. I'm just curious, do you happen to know how many different users you are getting per month or per week on both projects? Thanks.
I think we get now around 10,000 hits on the EUScreen website, which is not really impressive, I think. But what I think it's more, and also the number of hits to Europeana are might not, I don't know them, but I know that they're not really like will blow you away. But I think what is more important is that both EUScreen and Europeana are now doing lots of work on search engine optimization. So we are not expecting that people will go to EUScreen or Europeana as their first stop. They will go to a search engine. So we have to make sure that we are very well indexed there.
Does this work? Yeah, okay. First of all, congratulations with this amazing project. I sure know what I'm going to be doing in the coming weeks, so it's really amazing. I was just wondering, how do you get archives to give you their information? Do you proactively contact them, or how does that work?
Yeah, it's a very good question. And how much time do I have for an answer? Because the answer is quite it's quite diverse. If you go to say our friends at INA, the French Audiovisual Archives, they are really big, and they also have a very a clear mandate from their government that it is important to contribute to Europeana. So having a discussion with INA is very easy. They say, oh, I know about Europeana, and we know it's important. We are a public-funded organization, so we are contributing. So if you look at other archives, like TV Catalunya, which is a commercial broadcaster in Spain, they don't have the same sort of driving force. So we have to say to them, okay, contributing to this initiative is important for you because you might get more traffic. You can look at, you can open up your collection to researchers where they can then study your collection next to other collections, but it is a more difficult sale. So one is very top-down, ministry saying you have to contribute. The other one is more bottom-up, saying, okay, these are the advantages of you working with us. And then another answer to the question is that all the partners in this project receive money to contribute. So the sale is even more difficult if you say, okay, you have to contribute, but you're not getting any money. Yeah. But opening up metadata under a CC0 license, that's quite a leap for some. Because you have to imagine that this is really the capital of these archives. And catalogers typing away for many years and making these catalogs, and then here we come and say, okay, you have to give it away under a CC0 license. Okay, so. Any more questions?
No questions? We have plenty of time. You can maybe wake you up. I know it's late and everyone is tired. Anyway, thank you very much.
You're welcome.
Very interesting presentation, nonetheless, even though you were tired. I have some announcements to make.
I also have one more announcement.
Right.
I have flyers, and I'm not taking them home to the Netherlands.
Okay. You can throw them up into the air, and everyone can get their own. Yeah? Okay, yeah, sure.
So I didn't quite understand, where is it stored, all the stuff? Is it
to the servers in the respective countries, which is quite a headache because we want to have a very smooth user experience. So everybody has to comply to H.264. Everybody had to open up ports so we can do the keyframe extraction to have a. So it has quite some. It was quite some work into getting the infrastructure right. In terms of cloud storage, this is something that we are going to investigate in a follow-up project too. But I think also here the IPR will be quite a hassle. But I think that cloud storage might work for the smaller archives. For instance, BBC or RAI or the other really big ones, they already have their own streaming infrastructure. But maybe the medium size, say a library with a small audiovisual collection, they might want to sign up for this service. But it's a good question. And there was one on the back.
Hi, I'm from Red Clara in Latin America, and I would like to know, it's a splendid project, both of them. So I want to know, have you ever explored the possibility of taking this project to other regions?
Where are you from?
I'm from Chile, but I work for Red Clara, the Latin American network.
Mm-hmm. Yeah, so the idea of connecting audiovisual, collecting these different heritage collections is quite a universal thing. For instance, there's the Trove project in Australia, and there's the DPLA, the Digital Public Library of America in the States. So the the Europeana network is collaborating with these initiatives. So for instance, the Mint toolset that I showed is also going to be used within the DPLA. So there are, so ideally, what you end up with is a global network of all these collections tied together, which is going to be, well, this is on the to-do list for the coming years. But yeah, the discussions are happening, and I also hope that we can connect to Chile at some point. Yeah, one more.
You say everybody has to agree to H.264. That means transcoding in some instances, right? They have to pay that themselves?
Yeah.
Okay.
Oh, so yeah, did everybody get the question? So there's a, this is something that we, so we first got the grant, and then we had to negotiate with all our content providers about the specific conditions. Luckily, the archives that we are working with, they have quite good technical staff. Converting video files is something that archives have been doing forever. So that wasn't the big deal. The big headache was opening up ports so we can do the keyframe extraction. That was more difficult than explaining to them which codec they had to use. Yeah. So,
a somewhat related question is, this project has only been about exposing this content to the general public. Mm-hmm. So you don't deal with also with issues such as long-term preservation and being neutral to codecs and that sort of thing. So
there is so a lot of millions and millions of euros are being spent in digitizing these collections. So EUScreen sits on the access side, and there's a project called Presto Space, which created the so-called Presto Center, which is a competence center on digital durability. So we are working together with Presto Center to make sure that the archives that we are working with know about the standards that are being used on the digital preservation end. So the Presto Center, for people that would like to know more, they have quite a extensive website with all kinds of information. Yeah, and they're actually housed also at Sound and Vision, so they're just my neighbors. But yeah. So no more questions? Mm.
I was just checking out your site with iPad, and it doesn't seem to work. So I was wondering, are you not using? Yeah. I was just checking out your site with my iPad, and I just noticed that I didn't see any video. So yeah, I was just wondering.
I had the same thing with my iPad, and the reason for that is that it doesn't work on mobile platforms yet. When we designed this project in 2008, and then the iPad and HTML5 weren't yet. The HTML5 was on the horizon maybe, but touch interface were not. So this is also part of the future project to move to HTML5 and also move to these more open standards. And then, so if we have this conference, where is this conference next year? The Terina conference?
It's in Maastricht.
Oh, well, so when next year in Maastricht, it should work. But at the moment, it's only for desktops, I'm afraid. And the reason for it, when we wrote a bit, it wasn't there yet. Which is maybe a stupid reason, but that's the reason.
Can you please speak into the mic?
Yeah, I know it's easy to change, and I also know that our technical partners know how to change it. But I'm the technical director of the project, and I know that they're also working on the virtual exhibitions, which they also need to be working on. So sometimes that's the way it is.
I'm just a bit evil. It works on Android.
Ah, okay. Well, let's end it right there, I think.
Okay, thank you very much. Thank you very much for this excellent